All right, thank you once again for joining. This is another session in the Web3 Africa Monthly Workshop Series. And today we'll be focusing on smart contract auditing and protocol security by our wonderful speaker, Ephraim. He's here. He's going to introduce himself and then we'll get right into it. So thank you, Ephraim, for joining us.
Hi, good evening, everyone. I don't know if I'm audible.
Yeah, you are. Good evening.
Okay. So I'm Ephraim Chuku by name, and a smart contract auditor with Akil Audit. So yeah. So one thing I want to state first off before I proceed into explaining some of the key terms and what each of them do, and at the same time, I want this to be practical uh, and relatable to those who are already technical understanding what smart contract is, and those who are not technical enough, if there is any time you need to like ask questions, um, I don't know if the section permits for that. So I'm always available to like being cut short. So I'll explain some of those terms. So and also I did make this slide as small as possible because for anyone who is even into the field of blockchain development, they will know how much of resources are out there for you to follow up with, how much of thing you need to bury your head with, and a couple of other tasks. So I made this roughly, I think, 3, 4 slides, but the content in it will help us explain at large. So first off, what is smart contracts? Okay, before then, here are points of discussions I would be covering. Uh, what are smart contract programs? Why smart contract audits are critical? Why do we even need them in the first place? How to perform audit as a beginner. So as a beginner, I'll be introducing you to a roadmap. And yes, this roadmap might look so bogus, but trust me, at the end of a summary of the roadmap, I would admonish you what I would have done if I want to begin auditing as fast as possible. You have to maybe make one or two from it. And yes, uh, I did have a page for uh, ways we could level up our auditing skills. Uh, Although they are just minimal, I just brought a few of them because the more I was digging into, the more I was discovering more resources to add. So, what are smart contracts programs? So, smart contracts are self-executing programs engineered to carry out a term of agreement. And they're not just term of agreements, they are recognized parties that are recognized. So let me just explain in full. These are self-executing programs engineered to carry out a term of agreement between recognized parties without a third party interference. So as we go deeper, I would be making reference to this and uh, say, for instance, where attack occurs, that is the case of a third party interfering. So you don't want to write a smart contract and expect that just one person, a person who is not expected to interact with your contract, is introducing an issue to your contract, either to make all of your users' phone get stuck or either so we don't want all of that to happen. So smart contracts are self-executing. How are these self-executing? So before I go deeper into blockchain network, I won't go way more deeper. I will just touch the surface. So I believe you get the concept. So smart contracts are self-executing. These are programs where you tell them to do a particular operation for you, and then they keep doing it. All of these things, again, you get them deployed. This smart contract will be deployed on a blockchain network. And you could fashion the program to work in the essence that we need all employers in our company to provide one Ether. So Ether is the currency, the native currency used for sending token, currency Ethereum blockchain. So I'm trying to like see how I can make it easier for those who are not technical. So Ether is like currency, like our USDC, we know, our Naira, we know, or CDs. So it is what you use in for the Ethereum blockchain. So how do smart contracts work on the surface? So I was mentioning a company who wants to expect its workers to contribute the sum of 1 Ether to a contract. So the contract states that users working on this organization should be the one to interact on this smart contract. So you are excluding every other parties as well. So how do you try to like create a contract that will recognize this set of persons, and then only them can contribute 1 Ether? And so to enhance our smart contract, say after the contribution of 1 Ether, at the end of every week, we will give it to say we contribute at the end of every week, 10 person contributed 10 Ether. That's a big money. So 10 Ether should go to one person at the end of the week. So another 7 days, it goes to another person. So because there are 10 persons involved, we expect that at the 10th week of the contributions, the 10th person has received his money. But if it be a case where um, the sixth person didn't get his contribution after contributing to every other person getting the money, then definitely there is an issue happening in your smart contract. So definitely you want to find out why is the sixth person exempted in the first place. So um, before I proceed into why you want to find out issues like that, these programs, which are smart contracts, get deployed on the blockchain network and they share some attributes. So the attribute they share is they are immutable, especially when you're deploying to the EVM machine, a contract that is not going to change anymore. So on writing these smart contracts and you're deploying to Ethereum mainnet, you should be rest assured that when you deploy it, you have you have given it to the Ethereum machine to like operate. You cannot make changes afterwards. And that's why you call them programs that are immutable. And again, these smart contracts are deterministic. Yes, because say for instance, you are interacting with a contract that is called the staking contract. You know what this contract expects. It expects that at the end of the day, you are staking some Ether into it or some token into the smart contract. And at the end of the say after some weeks of contribution, you get some reward at the end of the day. If you do not get this reward, then definitely something is wrong. But the fact that you have written this contract and deployed it, you know it is aiming to achieve something. So that's why you call them being a deterministic program. And so how do we write smart contracts? Like I was saying something in relation to the blockchain technology you want to deploy to. The languages you use to deploy these smart contracts differ. I have a hyperlink linked to Solidity. I didn't add for the Viper, Rose, Cairo, Ethermint. So they differ. So if you're working with the Ethereum virtual machine, you intend to deploy your contracts on the Ethereum virtual machine. Definitely you want to work with Solidity or Viper. And very recently, there are a couple of them that are making it to fall. We have the off language. We have view writing in Yo. But the reason why we have most of these languages coming is because of the principle of gas that is used on the blockchain technology. So being a Turing machine, the concept of gas is trying to stop the issue of the outing problem. I don't know if any computer science is there. So one thing about the outing problem is the possibility of running an infinite loop, and then it continues to run. So because we are dealing with uh, a stack-based machine, a Turing complete machine, you definitely want to hamper that from happening. You don't want to be, this is to prevent instances of some complexity that could cause some computation from happening. And for that reason, you could the introduction of gas will avoid the instances of infinite loops. And so you want to pay for gas most of the time when you want to interact, when you want to call a transaction on the blockchain technology. So there is Solidity. So Solidity, if this if you're interested in writing or deploying your contracts to a Ethereum virtual machine, either use Solidity or Viper. And uh, for those who are familiar with JavaScript, uh, Solidity is tailored to look like JavaScript, still to look like, I think they got the idea from C# as well. So at the end of the day, I will be taking us through my tabs. I'll be creating some tabs, making some research about where you can quickly learn Solidity. There is Solidity by example. What Solidity by example do is it makes a list of topics that a new individual into a system can learn. Say, for instance, you want to try understanding how data types work. You want to see how functions look like in Solidity. So Solidity, by example, is a very good place. But trust me, you don't want to run away from the documentation, especially when you're doing auditing, because the documentation constantly releases a groundbreaking changes to newer versions, which you must pay attention to. And you can only discover that if you follow the documentation. Um, I hope my screen is still sharing. So we'll come
Yes,
back
it
to
is.
this. Okay, so we'll come back to this. I want us to maintain this. So why smart contract audits are critical? Why are they critical in the first place? Like I said, they are self-executing. After you've created your smart contract, you expect a function when being called to either give you a variable, or you're sending in an ether, or you're sending token into it. And then you have another function, let me say a function called deposit. So this function allows you to deposit tokens into the contract. Let's say it's a vault contract that helps you save up your money. And then if you use the deposit function to send into it, you expect that there should be a function called withdraw to withdraw this token. So if you check a contract out and expect you to deposit without a withdrawal, definitely you don't want to invest in that smart contract, because you know all of your tokens sent into that smart contract either get locked, or they get stuck, or there will be a means where you get lost along the process. So I will explain all of those things, and we'll check out some of the other issues that could arise when interacting with smart contracts. So first of them, I mentioned something about your contract getting locked. This could be sometimes as a result of some logical issues, some lapses in your logic that is making your contract either get stuck. Say, for instance, you have a smart contract that you want it to help you swap a token on Uniswap protocol, and on swapping on Uniswap protocol, help me calculate how much this person deserves from my own tokens. Okay, I don't want to make it more complex. Let me keep it simple. Say, for instance, you want to create a smart contract that interacts with Uniswap, and you are not familiar with Uniswap, and you expect that you want to call it, uh, swap exact it, okay, try to exact token for token. Say you want to call the swap exact token for token, but you use swap it for exact token. So there could be instances where this could be lost. One, because you do not understand how the Uniswap protocol works. And sometimes even if you do understand, you're not probably implementing some stuff rightly. And there is an issue of reentrancy. So reentrancy is a very, very, very uh, popular issue. And this is actually the hack that happened to the DAO hack. I think 2015. Yeah, my memory is failing me. But this is a case where your contract is interacting with other smart contracts, and uh, you have a function. You have a function that allows for people to make deposits into the smart contract. Yes, say you want to, yes, allow them to deposit into smart contract. And there's a function called withdraw. But this withdraw first off, um, let's say for instance, it fails to check how much you have in the contract. You just come and then withdraw how much you want to withdraw. So with the reentrancy allows for an attacker to uh, constantly re-enter that contract to do what it need not do, because there is no check that prevents that. An attacker should not withdraw more than what he made a contribution into the smart contract in the first place. So that's one thing about reentry. I would do a demo. I would hasten up, so I will do a demo of how this works. And there's an issue of integer underflow overflow error. So this is an instance where, say for instance, uh, you're adding, okay, say, how would I put it? Say you are going to add int 256. Let me use int 8 integer. So int 8, the maximum of int 8 is 255. Yes, and you are trying to add +1 to it. So there are instances where when you try to add +1, it should be 256, but because it has overflow, so unit 8 is like a wrapper that can take in a value from 0 to the raised to power 2 raised to power 8 minus 1. So sorry, it's not math per se, it's just how the unit 8 works. So it expects to take a value from 0 to the max of 255. But you're trying to add, and you have a value that is already owning to that is already wrapping a value of 255. You have a variable that is wrapping a value of 255. When you try to add way more than it, integer overflow implies that it would go beyond what is expected to wrap. And some of the time it either decreases the value or it increases the value. So depending on how the wrapper works or how you're trying to do your manipulation, you see this also work. And for price manipulation, price manipulation have often a time be related to how Oracle, like interacting with oracles, or if your protocol is interacting with oracles and you're trying to get the price of USDT from, say, Chainlink Oracle, and the Chainlink Oracle is giving you the price of, um, say, USD to Naira, just making an assumption, but I'm not sure it's exist. It just ether to USDC and a couple of all of that. But I'm making Naira, for instance. So you have a price oracle that gives you the price feed for USDC and Naira. So when your smart contract calls this contract, the price it gives you is say 900, and uh, another protocol it's stating that the price is 800. So what price manipulation is an instance of where a person has to um, uh, manipulate the price, knowing that your protocol sells is realizing a price feed of 900. It will want to, of course, buy a lot of Naira at the previous contract, knowing that the contract sells theirs for 800. And after he has bought a lot of them, so a lot of USDC from that contract, bought a lot of it from that contract. So he's buying at the rate of 800. So it comes to your platform to sell it because your platform is selling them at the rate of 900. So that's what price manipulation is. So most of the time, it's a case where you have to um, resolve this issue with checking out how your price oracle works. And there are other options to Chainlink as well. They have Trezor and a couple of them. And there's an issue of signature malleability. I would definitely come to our level, so I will see how these things work. So signature malleability is an instance where you expect that your smart contract should recognize a signature when a person passes it. And um, okay, so when a person expects to pass a signature into your smart contract, we've seen instances where a person could just pass in incorrect signatures, and your smart contract fails to recognize some stuff, especially when you're using the e-recover in, I think it's a native code in Solidity. So if you're using that, for instance, there are issues relating to it. So there are many others as well. If you click the others, it will take us to some of them as well. They are very, very, very many. And anyone coming into the space, I will admonish that he has a checklist. So this checklist is basically a list of issues you're always watchful of when carrying out an audit. So you definitely want to check out for floating, Solidity Pragma, what kind of version do they use, compiler issues, if any issues that happen with uh, Viper relating to the compiler, and a couple of them. So definitely you want to take note of all of these issues while you're going into an audit, so that as you continue to check their documentation and the code implementation, you want to be sure that they they did not at any point fall victim for one of these issues. So how can you start as a beginner? How can you come into this space as an auditor? You want to start auditing smart contracts, be it Solidity, contract writing in Solidity, with Viper, with Cairo. Trust me, you cannot escape the first aspects that requires you to understand this language. You can't jump into a Solidity code base and suppose you understand how variables work. You won't understand that from just looking at how the code. Definitely you'll be lost. You don't know what is happening to the functions. You'll say you're hearing something like function signatures and you're confused. So definitely you want to understand the language. The first thing you want to understand is, okay, you want to try out deploying a smart contract, of course. You definitely want to start understanding how variable works, how the functions work, how external calls work, how delegate call work, how can you make transfers. So like I said, I have Solidity, by example, doing a very good work in that regard. So it introduces you to all of this. And as a plus to it, the smart contract programmer guy is creating content to each of these topics. So right there, Solidity, by example, for those who are grounded in Python, definitely you can pick up uh, Viper, by example, and its documentation, and then you can catch up on how to deploy smart contracts before going into how to audit it. So say, for instance, you already understand how to write and understand the programming language in deploying smart contracts. You definitely want to be ready on reading documentation because it is not something you can run away from, especially when you want to begin an audit. Definitely, you expect the clients to provide for you the smart contract specification. So what contains the smart contract specification? You're requesting for a documentation, you're expecting for the functions in the contracts and how you expect them to interact. You're expecting how, if they have a white paper, you expect them to provide for you the white paper. So all of these things are things you will see down to. So you first begin understanding, oh, um, they have a function that allows us to audit, sorry, say you want to auction an NFT. So when a person creates an NFT, can he auction it? Can the owner of the contract take down my NFT that has been auctioned without me getting my money? So all of those things are things you will only understand if you visit the documentation of the project. And then I am an advocate of cultivating the habit of a research text-driven audit. So for a research text-driven audit, say you get an audit, it's smart contracts to audit for the very first time. Again, you definitely want to start researching what what other similar code has existed like this and what kind of issues have been arrived at. So you want to see, oh, the compiler version using this smart contracts could cause an issue, especially when you're using 0.5 or below 0.8. You want to see issues of integer overflow, very much related to versions lower than 0.8. So you want to check out all of these things if you do a research. If you don't do a research of how all of these things work, definitely you won't discover that there is an issue relating to it. Especially when you have a smart contract that has a bit of inline assembly and you're not familiar with how inline assembly work. You don't want to tell them, no, you don't want to do this audit. Definitely you want to check out a place that looks like, oh, this is how an inline assembly works. Of course, you have to go back to Fidelity documentation. It is there, and then you come back to the code. So you will be doing a lot of research, and there've been a lot of talks about who a smart contract auditor is and who a smart contract researcher is. Trust me, you want to wear both suits while auditing. You want to be at both ends. You are researching, you are as well reviewing the code. So, like I said the other time, there is a need for you to pay attention to a checklist. You should have a checklist. If you know, even though you don't have a checklist, there is a checklist people create every day. Especially if you go on Twitter, you see a lot of people creating alphas, checklists for where there are security tokens. There's a checklist for DeFi protocols you're auditing, and a couple of them more. So you want to have a checklist while carrying out an audit. Again, as a beginner, you need to know these things. So in the process of you understanding this checklist, definitely you want to do away with your checklist if there's no time. And then because by that time you already have them stuck in your head and you can remember them without even going through the checklist. And the fifth one, okay, yes, I said drill up your research skills. Look out for newly disclosed bugs. And yes, every day issues we are unaware of are being discovered. We've seen issues that lead to a payout of 6 million, 10 million, and all of that. So these issues are not just mere issues of re-entrancy. Oh, you just see how a person re-enters. No, they are way more complex than we know. And that is why you see a lot of companies creating post-mortem after the discovery has been made. You see a lot of companies are creating post-mortem of how this was possible. You definitely want to keep up with your research, or you need to continuously look out for newly disclosed bug. Hence, you might uh, maybe get outdated. And yes, the sixth one is learning. So, of course, the if you are well grounded with your research skills, you definitely want to keep learning. You want to see with the pace in the blockchain ecosystem, Web3 generally, there's a lot of new concepts coming out, a lot of new blockchains coming out. You want to stay at that pace. You want to understand, even if you want to major with just Solidity, definitely you want to keep learning. Like I said, there are breaking changes that are coming to fore constantly, and you must keep hold of it. So you must continue to learn to keep hold of it as a beginner. Even those who are even in the field, they haven't even stopped searching. They haven't stopped learning. And so yes, I have this, and this will make me end the slides, and then we'll go into discussing some of the topic. Um, yes. Yeah. Okay. Um, uh, yeah. So here's the roadmap. So please don't mind how long it is, but trust me, the Razor Sec did justice to this. Just so yes, I would try to like summarize them as fast as possible, and then I'll discuss on the need for you to be
Sorry,
tactical.
sorry, please. Can
Hello?
you zoom in?
Okay.
Can you zoom in?
Yeah, I can.
Okay, good. Thank you.
Okay. So I will just start from step by step, then proceed. So first off, definitely you're coming into the space of smart contract auditing. You want to understand blockchain itself. You want to see what it does. And anybody who has been in the space should know the Mastering Ethereum. Mastering Ethereum is uh, a very good book to start, especially when you want to gain ground of how blockchain works. I will open it so you see it has 14 chapters or thereabouts. Um, Yes, 14 chapters where you understand what Ethereum is, you understand the Ethereum basics, and thereafter you go into Ethereum clients, what they do, and the importance of cryptography cannot be disassociated from blockchain. So you want to know what cryptography is. There is wallets to understand because, of course, these wallets will be interacting with your smart contracts. They can't just, because they are self-executing, doesn't mean they can just start executing themselves. So you want to understand how the contract address is different from your EOA address when you look into wallet. there is transactions for you to understand for stuff that makes up your transaction when it is going to the blockchain. So you want to have some data with it, the gas you have to pay, uh, the if there's a receiver, you want to have a receiver, and a couple of all of that. So there's smart contracts and Solidity. If you're intending to build smart contracts with Solidity, there's a page for you to understand how this works. There is Viper. I am actually majored in Solidity. I use Solidity to like I started with developing smart contract Solidity and then delve into auditing. And yes, the smart contract security is uh is a wrap of the need for you to be tactical either while developing or you're auditing. So definitely you want to check out for some major or basic vulnerabilities. We'll see that as we go further with the roadmap. There are tokens you need to be familiar with. There is the ERC20 token, there is the ERC721 token you want to pay attention to. There is the ERC1155 and a couple of Ethereum other standard you need to be Ethereum standard you need to pay attention to. I think when we go deeper into the roadmap, you see they make mention of all of that. But trust me, when you have understood most of the things in this Ethereum book, definitely seeing them further again would be quite easier. Okay, there's a roadmap. I think so. Yes. Mm, Again, if you read the Mastering Ethereum, you'll see all the whole concept of the consensus mechanism, how they work. You want to generally differentiate between the work and stake, how work differentiates from how the proof of stake works. Very recently, Ethereum migrated to the use of proof of stake in order to make the uh, gas efficient when interacting with smart contracts. And for the step two, like I said, this is the part where it requires you to understand the programming language you want to deal with. And when you start understanding the programming language from the documentation, again, I said there is the smart contract programmer. So this smart contract programmer is the guy who created Solidity by example. You can just quickly open it. It should link us to a playlist on YouTube. So this will introduce you to how Solidity works, how the functions works, how star variable works, and a couple of them. For those who are intending to start developing with smart Solidity, this is it. There's also a video for Viper created by the same person. And yes, there is Securium. Um, say for instance, you understand Solidity in the space of a week. That's awesome. But of course, you want to go to Securium to start testing uh, some of their docs, some of their some of their articles as well. So because this make a list or this gives you an inkling of the Serenity documentation. So if you read up 101, 201, in a way you discover, oh, you're reading the Serenity documentation already. So I try to like admonish it. So imagine you've read this and then, yes, of course, you can't finish the documentation, but if you are the voracious type, trust me, it is something you always want to revisit. And for the breaking changes, like I said, it is something you want to pay critical attention to when auditing a smart contract. You have a smart contract using 0.50. What are the things you think they could be introduced into a smart contract? Definitely you want to see them from that aspect. So it is very, very important you know how to uh write the smart contracts language. So there's gas optimization. Actually, I'm sort of like smiling because as when I was going through this roadmap, when I used it to delve into auditing, some of the contents here were not here. So I believe the creator is always updating this. So for gas optimization, you don't want to build a smart contract where users have to pay a huge amount of money for gas just because they want to interact. And like I said, new programming language are even coming to resolve that, and that is off language, for instance. But of course, you want to see how you can make your Solidity smart contracts well optimized. Um, Kaden here created the gas optimization tips. He has the checklist as well of Solidity vulnerabilities. Um, so although some of this could qualify for gas issues, especially when you're auditing smart contracts, you need some informational issues. So this is where the gas optimization fall in. So you want to start identifying the need for I want to make mention of the need for you to not use greater than zero in your smart contract. You want to instead ensure that, oh, the amount should not be zero. So you do something like an exclamation mark and equals to. So I'm sorry I'm not showing you the code, but I have to be as fast as possible for gas optimization. There are a couple of them, supposing you understand Solidity. And yeah, the very first one is you need to understand is a development toolkit. So this development toolkit is used for you to carry out smart contract testing and debugging. There is ADAT. So ADAT is wonderful, but definitely there's a lot of comparison between ADAT, Foundry, Truffle, and a couple of them. But these development tools are very, very important, especially when you write smart contracts. You don't just want to deploy them straight up. You want to write a test that ensure that this function is doing what you want it to do. This function expects that if user do not send ether alongside, it should revert. So you want to see how that will fail if an attacker is not passing ether and calling my function. So with the use of ADAT toolkit, you can establish your project and then carry out several tests on it. So you want to see how much test coverage you've achieved at the end of the day and say, oh, my code is safe. Uh, this beta programming hub links you to how to utilize ADAT. If you open it, it will see how you can deploy ADAT and do some test case on it. There is Foundry. I haven't used the code editors before. Mm, there's Foundry, but Foundry is even more interesting because uh, Foundry is saving most of uh, the developers who do not like JavaScript. Don't make it loud. So people don't actually like the fact that they have to write uh, uh, the async await and then a couple of that. So you with the use of Foundry, Foundry is Solidity full based. You are writing your smart contract in Solidity. You are doing your testing also with Solidity. So the reason why I would admonish anybody picking up a development toolkit to pick Foundry is during the course of it testing Foundry, me so far, even when I try to understand Foundry, I I still continue to sweat because it makes me understand Solidity. Sometimes I expect it's not the usual way where you pass an array in JavaScript. You do that with Foundry. So it will help you understand Solidity if you pick Foundry as a development toolkit. The tenderly here was mentioned for the case where you need to debug. So say there's an exploit. You heard about exploits on Twitter. You can come in here. They have a premium, of course, but this tenderly allows you see how uh, allows you see how interaction happen, what external calls were made. So it helps you for debugging, making discoveries of issues, where issues fail. It tells you this is the part where it fails. So most of the time, if you have a revert in your Solidity smart contract that's insufficient funds. So with the use of Tenderly, Tenderly will indicate, oh, this is where the issue is. And it's stack traces. It will show you some stack traces of the functions called. Then you can easily trace and resolve the issue at the point of developing. And yeah, I was mentioning ERC standard, Ethereum standard before, under tokens. So here again, is it being mentioned for you to understand them? These token standards have issues that are relating to them. Uh, the ERC-20 helps us create a, a normal tokens. Most of the tokens we go to claim are created with the ERC-20 token standard. So you definitely want to use them most times in your contracts when building them, but you want to also pay attention to issues that are relating to them. I think very recently they are removing the in-place allowance and the place allowance in the ERC20 contract. And there is the ERC 721. There is issue of race conditioning relating to ERC20. So that is what the place allowance was trying to resolve. Let me be fast with how the race condition works. So say for instance, uh, ERC20, you approve a person 20, okay, let's say 200 token to use. So having approved the person 200 token, uh, you intend to in the future, because you discovered this person cannot finish the whole of 200 tokens. Let me change it to 150 token instead. So if a person knows that you are intending to make these changes, I can do something as the attacker here. Say, for instance, uh, let me call it Alice and Tom. So Alice gives Tom 200 token to use, but Tom discovered that Alice is trying to like reduce his allowance to 150 token because he cannot finish 200 token. So because of that, Tom will make a first transaction first to exhaust the whole 200 token in it. So you use it to say the instance, use it to purchase some shares. So on purchasing that shares, when Alice calls the approve function again, that is 150. Instead of the smart contract to update Tom allowances to 150, that is reduce the 200 to 150. What it will do instead is, because Tom has spent 200, it will give Tom additional 150 to spend. That is very hard, I know, without a code proving it. But I will try to fasten up with this, so we'll see how all these things work. Let me open this. Oh, it's not linking me to the code.
Sorry, please. Can you also share the link to that roadmap?
Yeah, sure, I will. Okay, I will share with the slide. It's just very, very, very small. Oh, let me just paste it. Okay, is there a place to, how can I? Okay, yeah, so I've shared it. Yeah, when you understand most of these standards, definitely you don't want to disassociate yourself from OpenZeppelin, because OpenZeppelin has most of these token standards and upper libraries. So upper libraries includes safe maths, there is possible contracts. So say you, for instance, you want to add the functions of the owner being able to post the contracts and then post later in the future. You want to, okay, does it link to? Yeah, so it links you to, so you want to solve issues of Markov proof. It is there. I think, yeah, that's under cryptography. You have these libraries to help you. So you definitely want to understand them, especially when you're building projects and you're not aware of all these things. You want to write them from scratch. If you check out these upper libraries, you definitely might see them, that some of the libraries that will help you instead of writing some tokens from scratch up. Um, there's the available contract. So available contracts is something that negates what I earlier said, that smart contracts, when deployed on the blockchain system, uh, cannot be changed anymore. So because of that, some interested persons are feeling the need for us to have upgradable contract, because there could be instances where you want to add more features to your smart contract, or you want to remove some features from it. So people were of the opinion that we should have some kind of contracts that can perform all of this. So definitely you want to see how this PROSI pattern works. I think yes, Smart Contract Programmer is a very, very, very good YouTube channel to follow, especially when you're doing Solidity and Viper. Yes, so it will tell you or to show you variety of available contracts that exist. There is the UUPS, there is the transparent. So if you check this, to link you to some of these available contracts. So the reason why I'm mentioning all of this is, say for instance, you know all these things in mind and you have a contract that is upgradable. Of course, you want to start looking at what kind of upgradable contract is it? Uh, what is it expected to implement and what it shouldn't implement, especially when you writing an upgradable contract and you see where changes is being made to storage. So there's a very, very, very common issue to upgradable contracts where you must not manipulate with the storage. If you do, you definitely might be you'll be affecting a lot of stuff in your smart contract. So this is step 7. Yes, and step 8 is over here. Yeah, so I was mentioning the need for you to understand a couple of smart contract issues. They are very, very, very important for you to. And if you start with security pitfalls from Securium, uh, let me at this point mention the need for you to follow Securium. So therein you will meet a couple of auditors who are grinding their skills, who are trying to explore the field. You want to definitely pay attention to Solidity versions. There are issues relating to them, so you always want to take note of them. There are a lot of them. So that was why I didn't list it, why we should do a critical audit. So you want to check out uh, some of these issues. We call it 101. There is a lot of issues. And if you check 201, there's a different kind of issue mentioned from 101. So you want to take note of how these issues look like. And yes, there's the SWC, Smart Contract Weakness. Okay, weakness classification. So again, um, most of what you find here I already mentioned in the smart contract security pit for 101 or 201. But for the SWCA registry, what makes it different is how it helps you understand the issue. Trying to, okay, uh, let's see, let's pick one at random, improper locking. Okay, oh, okay, yes. Okay, I think they even made some modifications. So why I will choose SWC is because of oh, some minutes, please, because I yes, find this will take me there. Okay. Yes, SWC links you to a piece of code that explains what is happening. That is why it is different from 101, 201. So if you use the registry shows you a piece of code that is right and a piece of code that resolves that issue. And let me pick another one called okay, uh, integer overflow extension, or you call it arithmetic. Mm, yes, there's something. Mm, let's pick your entrance. Okay. Um, I will just quickly just read through how the entrance looks like. So this contract is called the modifier reentrancy, and it has a mapping variable that takes note of an address to its balance. So if you come to interact with this, it takes note of your address and how much is in your address, how much is expected to be for your address. So and the token name is called name, and then we're interacting with a contract called bank. We're ensuring that it's uh, yes, we create a new bank. So we're interacting with the contract called bank. Um, so there's a function that is called airdrop. The contract has a zero balance and supports the token, give them some token. So expect this token, give them some token. So if you call the airdrop function, like the usual way they tell us, because we've met some prerequisite, you can go to their platform and claim airdrops. So when you click on this function, it gives you 20 to your balance. Any address that calls this function, it gives it 20. So supposing it meets these are called modifiers in Solidity. So this modifies what should happen to this function. So if you look at what the modifiers are doing, has no balance. So the modifier first checks that the person who has to who has to call this airdrop do not have do not have it doesn't have any amount at all before it claims. So supposing that an address has 10 10 new token inside, don't give it to him, just cancel it. That is what the modifier is doing. So it has no balance. And there's the support token modifier. So the support token is ensuring that um, okay, the bank you're trying to call is the supported. So it's let me call it. So you do an ABI.encode pact. It's do an encode pack of the new token and then do a kekak ask of in 256, ensuring that it uh it complies to this support token function. So that's what it's trying to ensure. So if you're calling this function airdrop, it do all of these modifiers checks.
Hi,
So
FM. So can you hear me?
yes, I can.
Yes. So we
I
have few minutes more, so I'll be able to take some questions. So few
okay.
minutes, like 5 minutes. Yeah. So we take questions.
Okay.
Thank you.
All right. I'll wasting up with that. So I won't be able to finish this, but I would just hasten up with other steps you need to, and then do a summary. So you definitely want to pay attention to some low-level languages. You want to see how inline assembly works because as you go deeper into the field, you want to see you want to understand how stubs work on the low level. That's why I'm saying you must understand inline assembly. You must see how opcodes, how smart contracts are uh, compiled uh, into bytecode, and how the opcode work on the EVM. When you are calling the function, how there's a jump I, there's a jump one, and a couple of them. So if you click on this, it will lead you to the EVM opcodes. So EVM.codes. Therein also you can run the opcode and see how it works. Uh, you want to pay attention to some CTFs, especially Ethernodes, capture the flag, and yeah, damn the vulnerable DeFi. Damn the vulnerable DeFi explains a lot of DeFi issues, flash loans, price manipulations, Oracle issues, and a lot of them. It will expose you to understanding some DeFi concepts. And if of course, you want to understand decentralized applications, it's not a must you read this, but I used to have a video I check as well, which is not here. So it's from a professor, had a couple of them, and he also visited their code base. So you want to start understanding this because say you want to join a place like Code for Arena, some of these projects over there implement these DeFi protocols. So you want to see how these protocols work. You want to see audits that have been carrying out on them as well. So there is, okay, I mentioned the flash loans issues as well. And yes, you want to pay attention to step 13, 14, 15, 16, 17. Okay, 18 is a thing you can 18 step 8 is 18 is something you can do at free will. Say you want to check out newsletters. These are things that keeps you updated. You can just check out the Ethereum paper if you want to know an in-depth of step 18. That's why I jumped to it. So these are things you can do while you're progressing in the field, just understanding. I know a blog thread giving you a lot of nice updated content. So you want to join communities like Communify, Securium, Each Security. These are where you see smart contract researchers and auditors always grinding, looking for one issue or the other. And there are papers, you are interested in papers. And I'm very sorry I need to mention this. They're very important as you move into the field. The post-mortems for Immunify, BloodSec, Slow Mint, Rect News, Tech Sheets, award Ashen Bytes as well. Ashen Bytes is from Kilodates. They create a lot of post-mortems and must open solo audits for everyone to see. You can have it open one of this. Solo date. So solo date is nice. The creeping team is so the ciphering team, my bad. The ciphering team are constantly building this. As an auditor, you want to see what is happening in other smart contract, or what has happened in other smart contract that was discovered. And for that sole reason, you want to make changes. You want to see issue of gas griffin. So the solo audit, it will give you a lot of reports. It's something you must do. You must constantly want to update yourself. This is what I mean by constantly researching. Because in the field, there are a lot of people that are willing to help, a lot of people who are willing to help by creating platforms like this. So yes, as you delve into the field, you must have these arsenals in hand. You will constantly be using Remix. Remix is a playground to quickly just run your Solidity smart contract and see how it works. Yeah, I have it open here as well. So with Remix, you can just simply just deploy a contract. It's as easy as just deploying, and then you test it, you try testing. I think the store, okay, you pass a value to store, and then it stores it. So because we are not doing Solidity development, I won't go deeper. So, but you can use Remix to test and audit. It's a very nice playground. There's a VS Code you use. There's Slitter. Slitter is an automated tool to help you discover some issues. But you must take note that some of the time they make false positives. And for that reason, you need to filter your reports that come from most of these automated tools. Um, there is, okay, this the checklist I was mentioning before. I'll show you another one. This is the checklist you want to take note of. You want to see what is happening to variables. You must understand what is happening to your variable, which you are auditing. There is a struct. If you have a struct in your contract, you want to see how changes are being made to your contract and your struct data type. And same thing for functions. If you are working with modifiers, did you forget adding a modifier, especially when you're dealing with access control issues? If the only owner is not there, anybody can call it and there could be an issue from there. So you want to check out most of these. Um, I know they might be much, but trust me, when you continuously check these things, they stick to our memory. External calls are very, 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 very critical. When you see them happen in smart contracts, you want to be sure that, especially say for instance, you're interacting with Uniswap token, and then you have a variable that takes note of reserves. But with interacting with with Uniswap, it has updated your reserves, and you are unaware of that. So you want to see how variable, of course, changes. It takes you back to how these variables are changing. How are they not changing? So with external cause, it could manipulate your variables and then an issue will happen. So that is why with this all of issues to check out for, that is why you see projects up in Coast Arena, despite being audited, they still get to find high severity issues, high medium severity issues. That is of high importance. Uh, that's of high impact, I mean. That will definitely severe the project. Yes. Okay. I'm ready to take questions now, and I think I want to be sure I didn't skip any.
Okay. Thank you so much, Ephraim. Even though I'm not
Thank you.
a smart contract kind of person, I still learned something. So it's question time. If you have any question, please unmute your mic or probably just type it in the chat box. So we have few minutes to take questions. Any question?